We're going to do one more conduction and insulation demonstration, and that's with the metal tray and the plastic tray. If you've got those handies, grab them out. But I want you to do the same kind of thing that we did with the spoons, the plastic and the metal spoons. Which tray, you can do it with your hands if you want, which tray feels cooler? Probably the metal one again, right? I mean, your face is a really good sensitive part of your body, but yeah, probably the metal tray. I want to show you something. On the back of these trays, I have a thermometer taped. Of course I do. It's called a liquid crystal thermometer. So take a look at the thermometer on this tray. Let's see if I can get it close enough so that you can see it. All right, do you see how this, where are we, is colored in a little bit? So I would say that this tray is probably between 64 and 66 degrees Fahrenheit, probably in the 65 degree area. Let's take a look at what the plastic tray says. Oh my gosh, it's the same thing. Even though it feels different, they're the same temperature. Why is that? One is a better conductor than the other. Which one's a better conductor of heat? The metal one, yeah. That's why it feels cooler, because it's sucking out heat energy from your body faster than the plastic tray is. On your piece of paper, under metal tray versus plastic tray, you need to write down that the temperature was 65 degrees for both, and tell me, why does the metal tray feel colder? Think back to the spoons too if you want. It's the same kind of concept. Same kind of concept. Why does the metal tray feel colder? Write that down and come right back. We're so close to being done with conduction demonstrations. There's just 3 more questions for you to answer. Number 11 says, draw how heat is being transferred when you touch the metal tray. I want you to think about 2 things when you try to answer this question. Number 1, which has more heat energy, the metal tray or your face? That's the first thing that you want to probably label on your drawing. Then, knowing that heat always travels from areas of more heat to areas of less heat, which direction is the energy going to transfer? Draw that with arrows. I'm going to leave these little prompts up on the screen for a little bit while you draw how heat is being transferred when you touch the metal tray. Be sure to pause the video, by the way. For question number 12, it's the same kind of concept. Draw how heat is being transferred when you hold the metal spoon with an ice cube on top of it. Here, let me get you an ice cube. Ta-da! Show me how that energy is transferring. You gotta think about those couple of things again, but how is the energy transferring in this scenario? So, Fiona wants to say that you've learned a lot about conduction over the last couple days and the last couple demos. The important thing to remember is conduction is heat transfer through contact. So objects have to be in contact with each other, okay? Conduction is heat transfer through contact. High five. Yes, good girl. When you answer question number 13, think about all 3 conduction demos we did in class. What did you think before we even started the demos, and what do you think or know now that is different?